In this method of section process, we can easily find the force in any member of our truss. Whereas in the method of joint, we need to find forces uh, from from each joint, and that could be a lengthy process, whereas method of section can be helpful, uh, which is a quite short process to find a force in a member which is in which the truss is very large, and you can find the force in any member by using method of section. For example, if we want to find the force in GC member or GF member, we can use this section method. In this section method, the first step is to decide how to cut the truss through the members where forces are to be determined. So that means if uh, the first point is the decision point. If we want to find the force in BC member, so we can cut it through here. But if we want to find the force in AB member, we need to cut the section like this. So the second point is that determine the support truss support reactions by using three equilibrium equations. So these are the supports, two supports, and we need to find reaction forces at these two supports by using three equilibrium equations. And the third step is to draw the free body diagram of that segment of the section truss which has the least number of forces acting on it. So these are the two sections. This is the left side, uh, right side of the this truss, and this is the left side. And we have drawn free body diagrams of both of the sides. But we can see there are less amount of forces on this left side of this truss, and it is easier to solve this left side as compared to this right side. So these are the few basic steps that are involved in method of sections. So next, in the next slide, we will do an example to understand further the process of method of sections for structural analysis of truss. In this example, determine the force in members GE, that means this member GE, GC, this uh, this second member, and BC is this member. So first step is to decide from where to cut this truss. So if we cut this truss uh, like this blue line which is already provided, it can give us all three members can be cut, and we can find the forces in all three members. So this is very correct sense of cutting this uh, truss. So also is asking you whether the members are in tension or compression. So the first step is to find the support reactions. So in the first step, we will find the support reactions. We can see this truss is supported at point D. This is point D, where you can see a roller support is given. So at the roller support, there is only one reaction. So this roller can prevent the motion in vertical direction only. So there will be only one reaction force, which is vertical component dy. whereas the second support is at point A, and this is a pin connection. I already know that this pin can prevent its horizontal motion and vertical motion. So there will be two reaction forces at this point A, AX and AY. Also, there are two applied forces of 1200 Newton at point C and 400 Newton at point E. So we need to find these three reaction forces. So to find these reaction forces, we will consider this whole truss to be in equilibrium. So we apply the equilibrium equation to this whole truss and to find these three unknowns, ax, ay and dy. So we start this by moment equation, which is sum of moments is equal to 0. The point of decision at this point is where to take, at which point we should take the moment. Moment should be taken always at the point where there are maximum unknowns. You can see in this figure that there are maximum unknowns at point A. There are two unknowns at point A, AX and AY. So we'll take the moment at point A. So this implies that this 1200 Newton force has a distance of 8 meter. This 4 plus 4, 8 meter, and it will rotate the truss in clockwise direction. 1200 is multiplied by 8 with a negative sign due to clockwise rotation. The second force is 400 Newton, and it has a perpendicular distance. This is the perpendicular distance, which is equal to 3 meter. And it will rotate the truss in clockwise direction. Therefore, with the negative sign, 400 multiplied by 3, and then this dy, which has a perpendicular distance of 4 plus 4 plus 4, which is equal to 12, and it will rotate the truss in anti-clockwise direction. So it will be a positive sign, dy multiplied by 12 is equal to 0. This implies that dy is equal to 900 Newton. So applying the moment equation at point A gives us the value of dy, the reaction force at point D. Now we can find other two unknowns, ax and ay, by applying the other equilibrium equations. Sigma fx is equal to 0. This implies that ax plus 400 is equal to 0. So it means that ax is equal to negative 400. So negative sign shows us that we have placed the wrong direction of ax. The ax should be on the left side. The correct direction of this ax is on the left side. So if we placed the correct direction of ax on the left side, it would be up with the positive sign. So in the next step we will find the value of ay. We have the equation of sum of forces along y-axis is equal to 0. This implies that we have the forces in y direction ay minus 1200, minus sign is for that it is on the downward side, and plus dy. Dy is already, we have already found the value of dy, which is equal to 900 is equal to 0, and this implies that ay is equal to 300. The answer is now positive. That means that direction of ay was correct. So these are the three support reactions, and now we will apply the method of sections to find these and find the forces in these members. We need to find forces in these members. This member is GE member, this is GC, and this is BC. So we have now a section, and we have cut this truss to this section A and A. The next step is to decide which side, this is the left side and this is the right side of this truss, which side of this truss has lesser amount of forces. You can see that right side has three forces, 1, 2 and 3, whereas on the left side there are only two forces. So it is easier to solve the left side of this truss. So we will now draw the free body diagram of left side. This is the left side of this truss, and you have now you can see that there are two reaction forces at point A, which we have already calculated, and you can see here this AX is equal to 400 and AY is equal to 300. And now these are the known forces, and AX is directing uh, towards left side, so it would be balanced by a force which is on the right side. You can see here we have placed the direction of FBC, the force in the member BC. FBC stands for the force in the member BC, and we have given it a direction towards the right. The second force, which is AY, this is AY, and it is directed on the upside, and it will be countered with a force which is on the downside. So FGC is the force in member GC, and it is acting downwards. And then this force GE is the force in the member G, and it is directed on the left side to counter the force on these two forces FGC and FBC on the right side. These two forces which are on the right side will be countered by this GE. So now we will apply the method of sections and find these three unknowns. These three unknowns, FGE, FGC and FBC. We need to find these three unknown forces, and we now apply the method of sections. In this method, we'll now decide at what point we should take moment. Uh, you can see here, if we take moment about point G, the force, there are two forces which are passing through point G. FGE is passing through G point and it has no perpendicular distance, so it will not produce any moment about point G. Similarly, FGC is also passing through point G. You can see here this force. This is the line of action of this force. This is the line of action of this force, and this is the line of action of FGC. So both our forces are passing through point G and it will not have any perpendicular distance. So there will not be any moment due to FGE or FGC. So if we take moment about point G, two unknowns will be eliminated. Two unknowns, that means FGE and FGC will be eliminated and we will left with only one unknown, which is FBC. So uh, this 400 Newton force has a perpendicular distance of 3 meter. You can see here this 3 meter is the perpendicular distance of this 400 Newton force, and it will rotate the truss about point G along the clockwise direction. So 400 multiplied by 3 with a negative sign. The second force is 300 Newton and it has a distance of 4 meter and it will rotate the truss in clockwise direction, in this direction clockwise. So AY is also with negative sign, 300 multiplied by 4, and this FBC is FBC have a perpendicular distance of 3 meter and it will rotate the truss in anti-clockwise direction, so it will be with positive sign, FBC multiplied by 3 is equal to 0. This implies that FBC is equal to 800 Newton. As you can see that FBC is acting away from this joint, so FBC is a tensile force. So we place a T here to show that it is a tensile force. So now we will now look at this figure again, and we see that if we take moment about point C, first we have taken moment about G. Now if we take moment about point C, then two of the forces FGC and FBC are passing through point C. You can see here that these two forces FGC and FBC will not produce any moment about point C. Only FGE will produce the moment. So these two forces will be cancelled out. So we now in the next step we will take moment about point C is equal to 0. This implies that first force 400 Newton is passing through point C. It has does not have any perpendicular distance. You can see this is the line of action of 400 Newton force, and it does not have any perpendicular distance, uh, and it will not produce any moment. Second force, 300 Newton, it has a perpendicular distance. This is 4 plus 4, so it will rotate the truss in clockwise direction, in this clockwise direction. So 300 multiplied by 8 with the negative sign. This third, this second force, FGE, which has a perpendicular distance of 3 meter. This you can see here, 3 meter, and FGC will rotate the truss in anti-clockwise direction, in this direction. So it will be with positive sign, FGE multiplied by 3 is equal to 0. This implies that other two forces, FGC and FBC, are passing through point C. They will not produce any moment. So FGE is equal to 800 Newton, and you can see here this force is pointing towards the G point, so it is compressing G point. So we say that this is a compressive force. We place a C here to show that this is a compressive force. So we have found FGE, we have found FBC, and only one unknown is known, that is FGC. So we can see that FGC can be found by applying the other equilibrium equation, which are F sigma Fx or sigma Fy is equal to 0. So we can use any of those equations. So if we use sigma Fy is equal to 0, so we now find only the y forces. You can see this this ay is on the upward side, so it will be equal to ay is 300, and this FGC is on the downward side, and it is neither in x or y. We need to find its y component. So y component is always with the sine theta. So negative sine FGC sine theta, and you can see that you already know that sine theta is equal to perpendicular over hypotenuse, and this small triangle hypotenuse is 3 and perpendicular is 3 and hypotenuse is 5. So sine theta is equal to 3 by 5. So we can replace this sine theta by 3 by 5, and we can now find the value of FGC. FGC is equal to, by replacing this value of sine theta 3 by 5, and we'll solve this equation to find the value of GC, which is equal to 500 Newton, and you can see that FGC is pointing away from point G. This is pointing away, so it will be a tensile force. So we place a T for tensile force. These are the three answers: FBC, FGE, and FGC. These were the three forces that were needed to be determined in the question. So in this way we can find any force in the truss by method of sections. Thank you.